So here we go. So Unit 1, creating Java programs. Seriously, as I do the videos, and if you do watch them and you can't hear something, just let me know because I will correct that. Because like I said, I do tend to forget and walk away. I was trying to get some mics, and we have a blue screen here. I don't want. Oh, that's for that. I wanted to make sure. Oh, I was sharing everything. Okay. All right. So this is the first unit, but we're gonna kind of back up before we jump into that, and we're gonna talk about some basics about creating programs and talking about what a program actually is. These are all our objectives. I'll kind of skim through some of these, not because they're not important. I'm just going to highlight the big ones. Basically, a computer program, it just tells the computer what to do. So everything we use, and again, think about your phones. Does everybody here have a phone? It's almost a dumb question these days, right? Everybody have a phone pretty much. This is a computer. The power in this thing is amazing, right? Compared to what it could be. I mean, the things that you can do on these devices are incredible. So these are the software sitting on here that someone like you or I would have written to do different things. The computer program itself operates at what's called a high-level language, the high programming language. That's high-level programming language. So it makes sense when you're typing stuff in to do different things. Print means print something to a screen or get this or do things like that, get input. That's called a high level. It kind of uses English-like statements. You'll see when we do some of this stuff. The syntax is the biggest thing with it. Every language has its own syntax. Some of the languages are very similar. C, Java, some of those are very similar. PHP has some similarities. It'll start to drive you crazy when you start going between languages because you'll forget, oh, this one needs a curly brace, or this one needs a semicolon. I forget. And you kind of forget that stuff. So the syntax is kind of the rules that are set up. The machine language, I'll go back for a second, is the most basic. It's the low level. Programming itself is, and I'm going to go over here. We're just very fortunate to program way back when in the 60s and 70s, and would have programmers that would actually they would do an assembly language. They would do inputs and pops and pushes and move information. Because when you're memory, doing things in memory, and that's what's saving it. When someone tells you I have a computer that has terabyte hard drive and it's got 16 gig of RAM, right? That 16 gigabytes of RAM is what's storing that, which allows you to run more programs and run them faster. The more gigabytes of RAM you have, the faster it'll run. A hard drive is the same thing. You're getting information from that hard drive. When you're getting that information, if you can get a solid state hard drive is, so most drives are mechanical. Get a picture of that. I'll show you. Most hard drives, the old-fashioned hard drive. Well, I shouldn't say old-fashioned, but they are hard drives. The way most hard drives used to work were like this, and they have this little arm here. It's called a stylus, and it would write on these platters magnetically, and it would write information on there, and that's how your information is stored. Right now, these computers, they have a hard drive like this. When we get tired of that, we want to spend more money, more expensive. You get an SSD, solid state drive. It doesn't have that mechanical effort to do that, and it's instant. So if you have a hard drive and you install like Windows on it, when you put on your computer or your laptop, it's up within seconds because it doesn't go through this whole process of moving a stylus on there. It goes fast, but a solid state drive is it's all, and you can't see it. It's all contained. It's all electronic. That's the beauty of it. So a lot of people, what they do is when they're updating their computers, one of the big things they do is update their memory, increase their memory, maybe update the solid state drive. But it still works pretty well. I want to lift my laptop up, but inside. And you notice the difference. Gamers love solid state drives because you're just the quicker interaction, things like that. Big video cards, all that. So anyway, so you're going to learn a lot of terminology if you've not learned any of this before, if you've not heard any of this before. And that's why I'm going to kind of go over it because I want you to understand everything. Because that's the biggest thing that scares people about technology is all the terminology. It's true. But you know what? Once you get past it, it's like anything. It's like cooking. It's like auto. It's fixing a car. You know, all that kind of stuff. You have to learn the terms so you know what you're talking about. All that kind of stuff. I do a lot of stuff around the house. I fix stuff, building stuff, plumbing, electrical, whatever. If I need a part, I have to go research to figure out what things I need. What to call it. When I go to Menards, Home Depot, I can ask the guy what I want. Otherwise, I like an idiot, right? I need a thingamaboom that's going to connect to my Hoogie Woggy that does the gizmo. The guy looks like an idiot, like I'm speaking Greek, right? I have to figure out, oh, I need an elbow joint that's going to go into my sink, blah, 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 whatever the case may be, figure it out. I need a 16 gig, I want an 8 gig RAM, yeah. To plug into my laptop to match my other 8 gig. Oh, okay, no problem, yeah. What do you want? I don't know, let me get back to you. There's things like that. You learn that. Your compiler interpreter. Some languages use a compiler and some use an interpreter. And they compile the code and they interpret it into statements and run. Is it one better than the other? It depends on the situation. A lot of languages like Python. Python is one interpreted language. I can take that executable, that program, and I can move it and put it in all of your computers, and all of a sudden I can use this program. It's kind of cool. And that's how when you get your downloads for your phone or your computer and all that stuff, a lot of times they download stuff, and they'll just download and update the executable file. Budgeting error, logic errors. Let's do this. Like I said, I'm going to promise you a program. We're going to talk about some of this stuff, but we're also going to write some code. Look on your computers to see if you've got the program JGrasp. I'm hoping you do. So you can open that up. JGrasp. It's free. You can download it at home on your computers at home if you want to. Some of you have your laptops. You can use that. You can see I've already got a bunch of stuff in here. Remind me tomorrow. Okay. I'm going to close some of this. There you go. So this is your workspace in JGrasp. You'll notice for me on my left-hand side, I'm not sure, right? These are all my programs. I've written just a couple of Java programs. I've been a little busy. So these are all my programs. And you'll notice this is my directory up here. I can change this to go to a different directory if I want. I can get stuff off there's my SSD drive, my disk drive. I can put a thumb drive in there, and I can pull it off my thumb drive. A big thing about programming too, which I'm going to say, and it's kind of annoying because I'm is being organized. Creating programs, straightforward. Like I just showed you for the assignment. So if we go back and look at the assignment for this week, you do it, you want. I'll ask students to say, you know what, do this. Just go on, let me go to Explorer. I'll go to Documents, whatever. Create a folder, right click, New, Folder. And then I'll do something like this. I'll just say U1, something like that. Underscore UDI for you do it. But then you got it. And then inside that folder is where you're going to create all this code. You go create the code. It's just a way to organize. So what happens is when we're ready, and we'll do this. In fact, I'll use this as my example. I'll go back, and when we're ready, we've got all the code in there. I will zip this folder up. I can zip it up with nothing in it, and I'll just show you that anyway. I can right click on it, and I can go down and I can click send to compress zip folder. Now it's empty, so it's not going to do it. So we'll do it again when there's stuff in there. But I'm going to leave this open. So let's go back to JGrass. I told you I jump around a little bit. We can create a new program. So I can click on File, New, Java. And there's nothing in there. You'll notice there's a line number there. There's a lot of stuff in here I'm going to kind of show you because I'm going to show you quite a bit. This is what's called an IDE, an Integrated Development Environment. There's a comment. You'll hear IDEs. Visual Studio is an IDE. That's the most popular one. It's one of the most popular ones. Microsoft created Visual Studio. In Visual Studio, you can program in many different languages. You can program in C, Java, J++, C#, all different kinds of languages in there. Companies noticed how popular and how well Visual Studio did. I mean, it's a great product. It really is. And so you may notice that when you look at the languages, like I showed you my RStudio one, which I know we're not learning R, but look at it. It's similar. They all have a similar feel. They have a workspace. They have other areas. I have a workspace. I have my files. I'm going to have my output down here. Okay, so I have an area of different things that I can do. Let me pull up one of my programs here just so you can see. The most popular program in the world is Hello Java, and we're gonna you will do this, but this is it. So this is my workspace. This is actual code that's written as a program that will run. If it's a properly created program with a syntax, which it is, I can in this case. In this IDE, I can click on my little plus guy here, and it says compile file. Or I can go over to the menu and just click on file, or I'm sorry, go to build, and then hit compile. And it will build it. You notice down here below, it executes some commands. So it's doing something. I'm telling you, can you build this program for me? And it builds it. Now, if I want to, and we're going to do this all again, so don't worry if you're not getting this. I'm kind of doing a high level and just kind of doing a drive-by just so you can get a taste of it. Like I said, I get tired of PowerPoint, so I like to have code. I can actually now click on this runner guy, and it will run this if it's correct. And look at that. Ooh, very exciting. Hello world, right? Okay. I know, not cutting edge stuff. You're not going to get a job at NASA doing this. You're not going to become a high frequency trader making millions of bucks doing this. But this is a stepping stone into doing some of this stuff. That's the idea. The structure is specific to Java of how you do this, and we're gonna do all that. But I wanted to give you a taste of it. So this is JGrasp. I can open up. You'll see I've got multiple tabs here. One's a blank tab. I can start doing different things with it. But as you'll notice, what I'm going to do is I'm going to start creating multiple programs, and I can have multiple open. I can open up another one here. Just drag it over here, and boom, I got other ones. And these are comments, and we're going to talk about all that. I put that in there. But again, I just wanted to give you a taste of what this is like, and we will walk through step by step. We're going to do this one together too. I just want to make sure you're comfortable with that. Okay. Let's just make sure. Let me pause this first. So some of the things we want to know is with debugging. Debugging is a huge thing. Rarely is it that you write a program, but the first time you write a program, it runs. Right? If it's a simple program like this one I just showed you, yeah, you could probably get to run, but you still may make a mistake, right? I can make a mistake and do something like this. Rebuild it, and now I get an error. It doesn't like it. Below here, I got an error that came up. It says, and we'll talk about all this stuff. This is a huge part of programming, doing the debugging part, figuring out what's going on. Or you might get what's called a logic error. So it compiles, it runs, everything is okay, but it didn't give you the output you expected. I gotta go look at that's a logic error. Okay, so somewhere along the lines you did something logically The compiler doesn't know logic in that manner. It just knows that whatever you do from a syntax perspective is correct. So I'll go back, I'll put this back in. And maybe I didn't want to say hello world, I want to say something else. I'll recompile and look at now it works again, and it should rerun again fine. So this is logic, but maybe syntactically this works fine, it compiled. But maybe logically I wanted to say something else. Well, I'd have to type it. I made a mistake, whatever the case would be. And that's what this is talking about in the PowerPoint. It's talking about logic errors. Maybe I did something incorrect. Something came out first or last. And as you get more into programming, it'll make more sense to you. Those of you who have programmed before, hopefully you have an idea of that. All it does is mean it works, the program works, but it's not doing it. We're getting into talking about, we're going to get into a lot of that, working with variables. Procedural programming is, in the most basic sense, is what's called a top-down approach. This program comes here at the top, it's my arrow, and then goes here, looks at this, and then comes to the next line and executes that. It's called the top-down approach. However, I can have multiple of these, and we'll do programs that will do that. These are called methods. This is called the main method, again, which we'll do. We're kind of dissecting the heck out of this one, which is fine. And you can do that. And that's called, inside each method is you're going step by step by step, but I can have multiples of these. And that's what's talking about here with objects, object-oriented. We're creating classes. Java is all based on classes, creating objects and object class. And this is a class. Notice here, public class hello. So I create a class called hello. And that's Java, that's how Java works. Everything is a class. I create this class, I can call it. And notice something also, and I'm going to repeat this many times because you might run into this issue. The class is called hello, and the file is also called hello. So those two have to match. So hello for the class and hello.java have to match. That's one of the most common problems. Keep it simple. You can name your file names, your classes, whatever you want. Theoretically, there are some keywords that you should not be using. However, keep it simple. What's mistakes? I have capitalized, lowercase, uppercase, this, make your life easy. This just a word of advice. I think they go into, yeah, object-oriented programs that talk about going with GUI. You ever heard the term GUI before? Graphical User Interface. Make something graphic. You're used to seeing that. Right now, we're using a graphical interface, right? Your everything you do pretty much on your phone or in an application on a website, that's a graphical user interface. It's graphical. That's what you're interacting with. Some of the old programming didn't have that. They were very primitive. There's other pieces here too. I want to go to this to show you about the classes. We're going to talk about classes. I like this one because I like the dogs. So you have a class called dog. That's your main class. Okay, that is the definition of the class. It's called dog. And it's got these different attributes. So name, age, breed, and in this case, shot status, whether or not it's got a shot. The dog has had his or her shots. You do not work with the actual dog class itself. What you do is you create an instance of that class. So in this case, they've created 3 instances of this class, one for Ginger, one for Bowser, and one for Roxy. And in there, they are able to then add the details for each of those attributes from that main class. You create it. What you do is, when you're doing this, and you can create any class you want. You'll be able to do this. There are classes out there that are set up for you, but as you go along in program, you'll be like, well, I need a class that'll do this or that. Or you may come to this one, you may say, you know what? I want another class. I want, I don't know, so weight. You know, what's the weight of the dog? Maybe I want that class, right? Things like that. You can just add another attribute in there to do that, and then you'd have more detail. So you can customize the class how you want, and there's ways to do it too. If someone creates classes, that's Java is open source and is very into sharing information and sharing classes. Someone may go out there home and you got this class. She's like, I really like this class. I like it. But I want to add some stuff. There's a way to extend that class. And we will get into all that. I can add more stuff, and now I can do more stuff with it. Right? But the idea is, why reinvent the wheel? The idea is, these are classes that are set up, and I'm organizing these objects, these class objects. That's what that's about. So again, back to the code, I have this class. This is a very basic class called hello. And in Java, in the world of Java, when you want to create a program, what you do is you use this main method. And again, we're going to do some. We'll do that through the PowerPoints, but I just want to show you. So you have this basic class set up, and it's going to do that. Y'all sticking with me? You're doing good for a late afternoon, early evening on a Friday. I know, seriously, I give you credit. You're doing good. So I keep going. So objects. Don't worry again about not getting all this. This is a lot of information. I will tell you that developers who have been programming for years, who used to do all the procedural stuff, they did COBOL, which is on the mainframe. That's old school. When they tried to make the shift over to this, they couldn't do it. It's a mindset change. Whereas like someone like us coming in and this is what we learned, it's no big deal. We're like, oh yeah, this makes sense, right? But some of the older, it's some type of mindset. When the next thing comes out and you have to learn that, it'll be a mindset change for you, and you'll be like, oh, okay. And it happens. It's always going to happen. Technology's going to keep doing that. So this method they're talking about here is a self-contained block of program code that carries out an action. What this method is just this. Here's a method. This is called a main method in this case. But we are going to create many methods. We can create all kinds of methods. I can create a method right here. I can create one. You don't have to do this. Public, static, void, my method. Right? I can do that. Open curly, close curly. And we're going to do all this stuff. So I've just created my own method. It's independent of this one. Okay? And that's what that is called. And it's self-contained. And what happens is when you're in that code, when I'm in this, this is private to this method here. When I have code in here, if I have code in here and I type something called int I is equal to 5 for an integer, and again, we will talk about all this stuff. This up here, this main method has no idea about this I that I just created, this variable called I that I created. I created an I, int stands for integer, so I created an integer called I to do that. And again, we'll do all this. So I kind of don't like some of this PowerPoints because sometimes they jump ahead, but I'm like, I have to explain this because I can tell you about this. You're like, what the method? Without going through this to make it easier. Some of this I'm going to kind of skip out because I want to get more into code. So they get into the biggest thing about some of the big ideas about object-oriented programming are encapsulation, which I'll just highlight because we're going to go over much more detail about it. Conceals methods is what that's about. Inheritance. The great thing about that is I'm able to take a class and I can inherit from another class. Okay, think about a family. You inherit things. You inherit genes, right? Genetics. Your hair, your eyes, your whatever. That's inherited. That's what that's involved. You can do the same thing with these classes. I can inherit things from a class. So I don't have to build a whole new class. I can just inherit things from one class to another class. It saves time. That's about efficiency. And then polymorphism just means, like it says, it's many forms. I can take something, I can manipulate it. And we will go into much more detail on these. This just kind of highlights it. This is the basis of object-oriented programming. Java, developed originally by Sun Microsystems. It's been around for a long time. Again, like I showed you at the beginning, it's still one of the top 10 programming languages around. In fact, we used to just teach Visual Basic. You ever hear Visual Basic? It's still out there. It's everywhere. It's been around forever. It's nice. It's a simple, graphical, basic programming language. But industry was moving away. And so we talked to industry folks and said, they're like, no, Visual Basic, do Java. So that's what we've been doing for a number of years. All right, so some of this, again, I'm not going to go through all this. You can go through these PowerPoints are right here. Okay. I don't need to waste your time with some of this. So let's do some more code. So let's do this. I'll let you look at some of this. Here we are. Here's our first one. So we can do that. So again, go into JGrasp, and this will be your hello. Even though we just did it here, we're going to do it again. So I'm going to do a new one, so we'll do it together. If you don't have line numbers coming up here on the side, there is a setting, and I always forget where it is. I think it's under Edit. Is it? Yep. Thank you. And right there, or Control L. So if you don't have it, you can put it on. If you do have it, you can do that. There you go. Okay. So normally what happens in Java, you start everything off with a class statement. I'm going to make it public, and we'll talk about it. So you can do public class, and I'll just do hello, just to make it simple. I hit enter, and then you're going to use curly braces. It's an open curly. That's above the enter key. Oh no, yeah, next to the letter P, and then close curly. Right? And you're gonna I do that a lot, and I apologize. You're gonna get tired of hearing me say that. I'm gonna close this one up. Discard edits. Okay. So right now I've just created a class, a basic class called public class hello. Very simple. Again, you'll notice that these public class are in purple because those are keywords. I can't use them anywhere else for variables or anything. And then hello is just in black. It's something I create. It's arbitrary. I can call it whatever I want. I can say 2, 3, whatever I want. So I'll leave it as hello. Now, in this case, I want to create a method like I showed you before. So public, I'm going to create a method again, public, static, and I will explain all these little pieces as we move along. Public static void main. Okay. And then we're going to do a left parenthesis. So public static void main. Public means it's public. Hopefully it's kind of obvious. What that means is any other methods could potentially use it. And we'll talk about a lot of this in much more detail. The void just means it's not returning anything. It's not giving a value back. Again, we'll do more detail. Main, if you want to run a Java program, you have to have at least one main method. So we will build some classes that will be separate files that will not have a main method in them. And you'll build them, you'll compile them, and it will generate a class file, and you'll see that, and I'll show you what I mean by that. But to use them, you always have to have at least one main method to then execute it, to do that, to run it. So when you see it running something like you saw me do hello, you had to have that main method. Okay, so main, and then you're going to have arguments, string, and I always forget it's string and then args. String and then args. Make this a little bit smaller here. And then the first was like that, yeah. You can see that. I'll put some other stuff. We'll add some other stuff into it in a second. So I create it. Now what I like to do typically, I'm kind of anal, is I like to save it right away. So I'll just click on, I'll do File and Save, or you can do Control S. There's actually 3 ways to save. File, Save, Control S, or there's this little thing here. For those of you who remember what a floppy disk looks like, if you've ever heard of a floppy disk, most students have never heard of it. If I hover over this little icon, that's what it is. It says Save File. That's really kind of a quick way to do it too. The first time you do it, you'll get a dialog box that pops up. And it says, okay, you want to save this. And you'll notice the file name is exactly the same name as my class name. So they do that on purpose. And it adds on the .java extension on there. That's the way that works. Now, I already have it on my system, so it's going to ask me to overwrite it, which is fine. I'll just overwrite it and do it again. I don't care. Don't worry about anything else. Now, you can change other stuff in here, but I'm just going to click Save. It's going to tell me it exists. I'm going to save over it. That's fine. Yours, it shouldn't give you that error message. So now I've got it saved. You'll notice my tab now says hello.java. My old one is gone. Okay. So I've got my class and I've got my main method. That's it. Right. Now you saw this other program here had one where it had some comments, and we can do something like that too. And that's what we'll also do in a second. There are some built-in what are called functions that are built in that you don't have to do anything special. You can just type them. So one is called, it's the printing. So you can say system.out.println. ln, then left parenthesis, and then quote, and I'm going to be annoying and just say something different. You can type whatever you want, actually. Make it a little bit smaller. Like so. And you can make white space doesn't matter. The tabbing doesn't matter. Java doesn't care about any of this stuff. This is all for you as a programmer or somebody else. And you have to think about it this way too. As a new developer, when you're writing stuff, it's helpful for other developers when you add white space. So by default, I just hit a tab and it indented there. There's a big joke. You ever see a show called Silicon Valley? HBO? Sure. Again, if you're kind of new to programming, this is how every language does this. So almost everything you're learning is applicable to every language. There's always some type of indentation. There's white space. You want white space. Now let's do this. We've saved this. Let's see if this compiles. Let's see if it actually works. So I'm going to go over here to this plus, and I'm going to click on the plus and see if what I did actually works. And yay, thankfully it did. Down there, it worked. You should see something similar on your screen. And I'll explain those too, because we're going to run out of time. Now I can actually click on the little running guy and see if it runs. And mine says the other day I saw a bear. So it ran. And it says complete. So hopefully if you typed it correctly, it complete. Now I can mess stuff up. And don't do this to yours if you got it working, is I can take my semicolon out. Every line in Java ends with a semicolon, except for some things like the methods. If I take that out and I recompile, I will get an error. And it's going to even tell me. It's actually kind of nice. It tells me, hello, Java 5, gives me the line number, error, semicolon expected. So it tells me, hey, dude, I think you want to put a semicolon there on line 5. Now, typically, sometimes it's on the line, the error is on the actual line, but sometimes it actually may be on the line above it. So if you have multiple lines of code and you get an error on one line, what will happen is the error will be generated, but it'll stop at that next line of code. And then all you do is look up. So if you're not sure, look at that line and look above it too, just in case. And that's just kind of, and that's with any line. So, oh yeah, okay, so do the semicolon again. Let's save it again. Actually, I don't even have to save it. I can just recompile it. It'll save it. And it built, and okay, it was good. Yay. So you've written your first Java program. Very exciting, I know. So a couple of things I want to show you. On my left side, here's my program, Hello Java, right there. But you'll notice above Hello Java, hello.java is a file called hello.class. Whenever you build your program, there. So what I'm going to do is go right here. You don't have to do this. I'm going to right click on it. I'm going to delete this. This is just a file. Yep, deleting it. Goodbye. It's gone. Now watch this. I'm going to clear this out. I am not going to rebuild my hello file. My class file is gone. I'm just going to run it. Oh, it's going to compile it. So what it'll do is it compiled it, generated the class file for me, and then ran it. Sometimes, depending on the situation, if the class file is not there and you try to run it, it may give you an error. It's like unable to run. You may get an error. So just something to be aware of. It just depends on this. Sometimes it's very nice, and the other IDEs like NetBeans and Eclipse are also very nice, where they will automatically build it. Oh, you want to run this? Oh, wait a minute, there's no class file. Let's build it and then do it. And then it'll do that, and it's kind of cool. So I just want to show you. So that it actually generated that class file, and that's where all these are. So all these are files that were built. When you hand in your homework, what I'm going to ask you to do is do that. So what I'm going to do is, let's see. So that's right there. I'm going to go back to that folder that I created before. Where is it? So UI. So what you could do is you could actually go and you could take that. Now, this program, I should have it developed in that area. Where is this? This is under Develop in Java. Let's do this. Let's go documents, develop. So here's all my programs. So what I was hoping you would do is create a directory. Now you'll notice I have a directory here called under my documents called develop. I have different languages. So like I have HTML, Java, JavaScript. I'm just trying to separate them. So under Java, which is where all these are, you'll go down and I'll find my hello program here. Now what you can do is when you originally save your file the first time when we saved it, you could save it specifically to the folder that you want to save it to. Now mine, I just saved it by my default. So, and also we can do that. But I want to show you, and let's do this. I'm going to go back to UD1, Java. So what I'm going to do is I'm just going to make a copy of this and put it in this folder for us for right now. Like that. So I have that in there. So let me do the, I'll tell you what, I'm gonna close this one and I'm gonna open the one in my folder that I just created. Let me do this, give me 1 second. I'm just gonna drag this over. And the way you can do that is if you go to a folder, you can literally just left click and drag it right into there and it will put that in there like that. Yay. Okay. Because one of the other assignments was one was hello and one was hello errors, and then you have a hello too, so you have a couple of them. And one of these is adding comments to a class. You can combine a couple of these together. That's okay. Just tell me. Now you don't have to, because one of them is comments, and I'll show you. We're gonna do comments too. Let's see here. So let's go back here. Okay. So I am now working. If you look at the top, my directory, it's under. I'm working in the U1 YD1 directory. I have my hello. You can stay where you are and what you're working on. That's okay. If you want to make a copy of something you're doing, you can always do file, and I can do save as. But this is what I recommend doing. So we want to, I'm going to go back to the assignments. I want to create a hello. Let's create a hello 2. I have a hello. I'm going to create a hello 2. That's another assignment. So let's do this. I'm going to go to JGrasp. I'm going to do this. I'm going to type 2 here for hello 2. Don't save it yet. Don't do anything. Just do hello 2. And then I'm going to do file, save as, and because I changed the class name, it picked it up and it automatically at the bottom, hope you notice, it says hello2.java. So it automatically makes the file name hello2. I'm like, cool, that's what I want. So then I hit save. Now mine's going to overwrite. No, I don't have one. So now I'm in the same one, but it's hello2. Hello is not gone. Hello is still there, but now I have a hello and a hello2. And you can do that with any program. So if you didn't catch that, I'll do it again. So I can change this to 3. Change that to 3. File, save as, and then you see hello 3. There you go. I'm not going to do it this time. Now the reason I'm telling you this is it's going to make your life easier because a lot of times you're going to just copy programs, sections, or big pieces of programs. It's a lot easier sometimes to copy this whole program and then pull out stuff that you don't need. It makes life easier. Why reinvent the wheel? Why redo everything? You can do it however you want. I'm just showing you this way. So for this one, all I want to do is add some comments. So I'm in hello 2. I'm going to do is go to hit enter a couple times and go up to the top. There's a couple ways to add comments in Java. I can do / like that. Did I do that the right way? I always forget. No, it's // this is a comment. And what that means is it's not going to execute. It's not part of your code. So again, I can run my code and it compiles. And what a lot of people do is, and this is what I'm going to ask you to do when you do each of your programs, is in there is you'll type something like this, name, and I know it's kind of redundant in this case. So type like hello2.java. And we do this in my jobs, any job I've been in. You type the name, the author. So you're the author, so I'll put my name. You put your name in there, Sivankas, and you put a date. In this case, the date is 9/6, like so. Now you could go further and do something like purpose or description if you want. Display. You don't have to. something like that. You can get fancy. I usually do stuff like this. I can do this, do an asterisk, make it look nice. Copy that, paste that, make it go down. Oh, go down there. Oops. Paste that. So now I've got it on block. Then what you can do is you can just literally, if you want, just take this whole block of code and put it in each of your programs. Just change the name and the date and all that stuff. But at least you've got this basic block of code. That's one way to do comments. There's another way to do comments too, which I'll show you. Without all the slash slash, works the same way. I do slash star. I'm going to show you this again. Pay close attention. It's really simple, but here's what's going to happen. I'm going to do a slash and a star. Notice that it changed the colors of all my code. Right now, it thinks everything is a comment. So that what I'm telling the interpreter, the Java interpreter, is I'm saying I'm beginning my comments. I enter a couple of times and then do star slash to close it. And now anything in here is a comment. So I could have done this whole block the same way, like that. In fact, most people do it this way. When you're typing a lot of text, a lot of people just do this, do slash star, do all your comments and then do that. If you're doing 1 or 2 lines at a time, people will do slash slash. But there is no necessarily best practice. If you do it either way, it doesn't matter. They both work. They're both correct. And again, and what I'm going to tell you, and for those folks at home listening, is as long as your code works, your program works, that's fine. That's what I want. Even with the exams or anything like that, I'm not one of those people. I've taken tests like this, and it drives me crazy. Where some obscure fact on page 32 in the book is on your test. I don't do that. If you have the overall concept and you understand it and you can write code, you're fine. You should be just fine. It won't be a problem. Like I said, especially considering this is a Friday afternoon class, evening class, I want to make this a little bit more fun, hopefully. So this was right away. If you did any of this, and you could actually hand this in for both of them, you're done 2. I was hoping to do more. The other one is just compiling class. It has you put an error in there. That's it. That's what that one does. And then the dialogue. Let's see the dialogue. Let's see. You know what? I've got my. Oops. I have my online book here. Chapter 1. I don't know how much you've looked at the different books. This one's pretty good actually. The UDoITs are nice. If you haven't experienced it, I'm going to go through this really quick here, make sure. And then I know you guys want to get out of here. Give me 1 second here. Talking about what we just had, inheritance, polymorphism. Again, you don't have to have it all memorized down. Just be comfortable with it. And I will repeat myself. I am known to do that. There you go. There's your first class. There's a sample code in there. What I would do as a programmer, and what I've done, is I literally take all the code I can find, and I try it myself. Try it yourself. Run it yourself. There are online, for those of you, if you don't have a system at home, or you have a system and you're having issues with JGraphs or anything like that, because you can install it anywhere, there are actually online compilers that you can use. You don't even have to have it installed. You can go online and use it. Some students would do that too. Doesn't even make it. Where's the first one? Doesn't show. I had it here before. Understanding first class. We talked about that. We talked about that. Okay. Chapter 1. Indent style. Yeah, talking about here's the comments, indenting. So again, everything we talked about. UDoIT. Here's your first application. That's what I'm talking about. There's your UDoITs. Okay, hello world. But it takes you through it step by step. This is what you do. Type the class header, do this, do that, do this. If there's something that doesn't make sense, just let me know. But it's pretty good actually. The UDoITs are pretty nice. I like those. So you'll kind of follow those, and that's what those are in the assignments. Sorry, I keep going all over the place. These are all those UDoITs. You kind of follow those. And then if you're comfortable with those, you can do these. Comments. I mean, we kind of did that one already, so stop there.